So here it is told that given below are two statements. One is labeled as assertion A and the other is labeled as reason R. So assertion is given two identical balls A and B thrown with same velocity U at two different angles with horizontal attain the same range R. If A and B reach the maximum height h1 and h2 respectively, then the range is R equal to 4 root over h1 h2. So now if they are having same range, if range of R1 and R2 is same, that is equal to R, then the angle of projection for the second ball that should be equal to 90 degree minus the angle of projection of the first ball. So it means that we can say that if the angle of projection of the first ball is alpha, then angle of projection of second ball will be 90 minus alpha. So now therefore the, or I can say if this is theta, then this will be 90 minus theta. Okay. So therefore R1, or therefore the horizontal, yeah, the maximum height for the first ball, that will be u square sine square theta by 2g, and the maximum height for second ball will be u square sine square 90 minus theta by 2g, which is cos square theta. So this is u square cos square theta by 2g. And then, and therefore the range, as we know, range will be equal to u square sine 2 theta by g. Now, if we do h1 into h2, that will be equal to u square sine square theta by 2g into u square cos square theta by 2g. So this will be u power 4 sine square theta cos square theta by 4g. So this we can write u square sine theta cos theta okay, this is 4g square. Okay, this is 2 u square sine theta cos theta by 2g whole square, or this you can say u square sine 2 theta by 4g whole square. It means therefore I can say h1 h2, that is nothing but r by 4 whole square. So therefore r by 4, that will be equal to root over h1 h2. So therefore the range that we can say, that is 4 root over h1 h2. So then the reason is product of the said heights h1 h2, that is equal to this. So hence the reason also is the correct explanation for the assertion. So both A and R are 2 and R is the correct explanation of A. So option A is the correct answer. And here it is told two buses P and Q start from a point at the same time. Two buses P and Q start from a point at the same time and move in a straight line, and their positions are represented by xp as a function of t, that will be equal to alpha t plus beta t square, and xq of t, that is equal to ft minus t square. At what time both the buses have same velocity? So here it is told the xp of t means it is the position of the bus P, is the position of the bus P at any time t, at time t, Similarly, xqt is the position of the bus q at any time t. So therefore, the velocity of the bus p at any time t, that will be equal to dxp by dt. That is equal to so this will be equal to alpha plus 2 beta t, and vqt, that is equal to, that is the velocity of bus p at any time t, that is equal to dxqt by dt. So that will be equal to f minus 2t. So it is told that at what time both the buses have same velocity. So this and this will be same. So Vp of t, that is equal to Vq of t at which time, that is asked. So that will be alpha plus 2 beta t, that is equal to f minus 2t. So therefore I can say this 2 beta plus 2 into t, that is equal to f minus alpha. So therefore t will be equal to f minus alpha by 2 into beta plus 1. F minus alpha by 2 into 1 plus beta. This is the answer. 2 into 1 plus beta. So option D is the correct answer. Then here it is told projectile is projected with velocity of 25 meter per second at an angle of theta with the horizontal. Projectile is projected at an angle theta with the horizontal at with the initial velocity of 25 meter per second. After t seconds, its inclination with horizontal becomes 0. So it means its inclination with horizontal becomes 0 at after t seconds. So at t seconds, it will reach the maximum height. If r represents horizontal range of the projectile, the value of theta will be r is the horizontal range. So therefore, r equals to u square sine 2 theta by g. That will be 25 square into sine 2 theta by g. And at t second, it reaches the maximum height. So the value of the angle theta with the horizontal at any time t, that is given as tan theta equal to vy by vx. So if theta, angle theta at time t is 0, it means vy will be 0 at time t equal to t. So therefore vy equals to uy minus gt, that is equal to 0. So therefore t will be equal to uy by g, that is equal to u sine theta by g. So t equal to u sine theta by g. Now it means t equals to 25 sine theta by g, that is 10. G is equal to 10. So 5 to the 10, 5 5 is 25. So sine theta equals to 2t by 5. Sine theta equals 2t by 5. And r equals to 25 square u square sine 2 theta, that is 2 sine theta cos theta divided by g. G is equal to 10. So 2 5s are 10, then 5 5s are 25. So r equals to 125 sine theta into cos theta. Therefore, r equals to 125 into 2t by 5 cos theta. 5 2s are 10, 5 is 25. So It means cos theta will be equal to r by 50t. R by 50t. Therefore, if we divide these two, then we will get tan theta. Tan theta will be equal to 2t by 5 divided by r by 50t. This will be 2t by 5 into 50t by r. 5 tens of 50, so that is 20t square by r. T square by r. 20t square by r. So therefore, cot theta I can say that is r by 20t square. So therefore, theta will be cot inverse of r by 20t square. Theta is cot inverse of r by 20t square, or tan inverse of 20t square by r. So option D is the correct answer. Then here it is told an object is projected in the air with initial velocity u at an angle of theta with the horizontal. The projectile motion is such that the horizontal range is r. So this horizontal range r is maximum. Another object is projected in the air. So the projectile motion is such that the horizontal range r is maximum. So hence, therefore, if r is maximum, then angle theta that should be 45 degree. Another object is projected in the air with a horizontal range half of the range of first object. The initial velocity remains same in both the case. The value of the angle of projection at which the second object is projected will be dash degree. So the second object is suppose projected at an angle theta 2 with the same initial velocity u, and here r2 that is same as half of the range of first object, so half into r. So the maximum horizontal range that is given as u square by g. So r2 that is u square by 2g. So then theta 2 is how much? That is being asked. So this is equal to u square sine 2 theta 2 divided by g. So u square cancel, g square, g will cancel. So now sine 2 theta 2 that is equal to 1 by 2. So therefore 2 theta 2 that should be equal to 30 degree. Therefore theta 2 should be equal to 15 degree. So the answer should be 15 degrees. Here it is told a ball is thrown vertically upwards with an initial velocity u that is 19.6 meter per second from the top of the tower. A ball is thrown vertically upwards. So from the top of a tower it is thrown. So let's say this is the tower, and from the top one ball is thrown vertically upwards with initial velocity u which is 19.6 meter per second. The ball strikes the ground after 6 seconds. The ball will strike the ground after 6 seconds, means at t equal to 6, and it is thrown at t equal to 0. The height from the ground to which the ball can rise will be the height from the ground up to which the ball can rise, means this height has been asked. So if the height of the tower, that is small h, so it means g is equal to 9.8 meter per second square, which is acting vertically downwards. So if we take vertically downwards as positive, then vertically upwards will be negative. So then therefore we can say s will be equal to ut plus half at square. Now the total displacement in 6 seconds, that is h meter, and that is equal to ut. U is 19.6, that is minus 19.6 into t. T is 6 seconds. and plus half g 9.8 into t square, that is 6 square. Therefore h will be equal to minus 19.6 into 6 plus you can say half into, that is 2 18s are 36, 18 into 9.8. So this we can write, this is 9.8, I can take common into 18 minus, this is also 9.8 into 2, 2 6 are 12. So that is 9.8 into 6. So it is 6 8 are 48, 6 9 are 54, 5, 58.8 meters. So the height of the tower is 58.8 meters and the height till which the ball can rise up. Therefore, this length x also we have to find out. So therefore, x that will be equal to u into t minus half gt square. Or I can say v square equal to u square plus 2s. At the topmost point, the velocity will be 0. So I can say v square equal to u square minus 2gx. So 0 square equal to u square, which is 19.6 whole square minus 2 into 9.8 into x. Therefore, x will be equal to 19.6 square by 19.6. So this is 19.6. So therefore, the maximum, so therefore, the height from the ground to which the ball can rise up, that is k by 5. Therefore, the maximum height from the ground up to which the ball can rise, therefore the maximum height to which the ball can rise, h, that will be equal to h, which is equal to h plus x actually. H is, we have already found it, 58.8 meter plus 19.6 meters, which will be equal to 6 plus 8, 14, 9, 10, 18, 78.4 meters, which is equal to k by 5. So therefore, k will be equal to 5 into 78.4, which is equal to, which I can do, this will be 784 by 2, that is equal to 2. Since y 5 can be written as 10 by 2, so 10 into this is 78.4. So 784 by 2, so 2 3s are 6, 2 9s are 18, 2 2s are 4, 392. So the value of k is 392. And here it is told two inclined planes are placed as shown in the figure. A block is projected from the point A of inclined plane AB along its surface with a velocity just sufficient to carry it to the top point B at a height 10 meters. After reaching the point B, the block slides down on inclined plane BC. Time it takes to reach to the point C from A is time it takes to reach, okay, just sufficient to carry it to the top point B at a height. Okay. So it means when it reaches the point B, its velocity will be 0 and then it slides down again on the inclined plane BC. Time it takes to reach the point C from A, that is T into root, which is root 2T plus T seconds. The value of T is, so T we have to find out, and G we have to take it as 10 meter per second square. A block is projected from the point A, inclined plane AB along its surface. Okay. So it is, its initial velocity is u, suppose. So here the acceleration there will be a retardation actually. So here G is acting vertically downwards. So along the incline, this will be 45 degrees. So this will be G sine 45 degree. And this length AB, that will be equal to 10. So AB sine 45 is 10. So AB by root 2, that is 10. So AB will be equal to 10 root 2 meters. 10 root 2 meter is the distance from A to B. So this 10 root 2 meters, that will be equal to S displacement, which is equal to UT. Let's say it takes time T1 to reach the point B. So I can say it is UT1 minus G by root 2 minus half AT square, T1 square actually. Actually, U also we can find out. V is equal to U minus A into T1 minus G by root 2 into T1. So V is 0, 0 is equal to U minus G by root 2 into T1. So therefore T1 will be equal to root 2 U by G. So we can find out U. Therefore AB is 10 root 2, 10 root 2 equals to U is equal to actually V square minus U square by 2A. 0 minus U square by 2 G by root 2. That is acceleration is also negative, so minus will get cancelled. So 10 root 2, that is equal to U square by root 2 G. Therefore U square equals to 20G, means U equals to 2 root 5 root G, 2 root over 5G. Therefore T1 that is equal to root over 2 by G into U is 2 root 5G. So that is okay. It's 2 root 10 by root G. G we can take 10. G is 10, root 10. So 2 root 10, root 10 will cancel. So T1 is 2 seconds. Now from B to C, it will take time T2, let's say. So then we can say the BC length, BC by, which is BC sine 30, that is equal to 10. 10. So BC by 2, that is equal to 10. So BC length is 20 meters. 20 meter is the length of BC. So BC length, that is the displacement that is equal to so here also when it will reach the acceleration is G This is okay. This is 30 degree. This is 30 degrees. So this will be G sine 30 degree. So it means G by 2. Acceleration is G by 2 downwards, means down the incline the acceleration is G by 2. So then S equal to ut, u means v1 into t. V is 0, actually vt plus half at square means t2 square. So therefore the displacement, which is 20, that is v1, that is 0 into t2 plus half into G by 2 into t2 square. So therefore we can find out t2. So 20 equals to 10 by 2 and 10 by 4 into t2 square. So t2 square, that is equal to 80 by 10. So 8. So tt equals, so t2, that is equal to 2 root 2 seconds. So therefore t1 plus t2 is the total time that it takes to go from A to B then to C. The time it takes to reach to the point C from the point A, that is t1 plus t2. So that will be equal to 2 plus 2 root 2 seconds. That is equal to 2 into root 2 plus 1 seconds, which is equal to t into root 2 plus 1, which has been told. So it means t will be equal to 2. So t equal to 2. So the value of t is 2. Then here it is told a ball of mass m is thrown vertically upwards. A ball of mass m is thrown vertically upwards. Then another ball of mass 2m is thrown at an angle theta with the vertical. At an angle theta with the vertical. Both the balls stay in air for the same period of time. So the same period of time. So here the time of flight for the second case, that is equal to time of flight for the first case. The ratio of the heights attained by the two balls respectively is 1 by x. The value of x is. So the time of flight for the first ball, if it is uh, projected by an initial velocity u1, so that will be equal to 2u by g. Since we can say velocity, so the displacement is 0, that is equal to u1 into t minus half g t1 square. So if we solve it, then we will get t1, that is equal to 2u1 by g, and t2, that is equal to similarly, that is 2uy by g. So the y component of the initial velocity u2, that is u2 cos theta. So it will be 2u cos theta, 2u2 cos theta by g. So these two are same. So therefore I can say that 2u by g, that is equal to 2u2 cos theta by g. So 2 by g will cancel. So cos theta, that is equal to u1 by u2. Cos theta is u1 by u2. The ratio of the heights attained by the two balls. So the height attained by the first ball, that will be equal to v square minus u square by 2a. A is minus g. So that is u1 square by 2g. And height attained by the second ball, that is also uy square by 2 and 2g. That is u square cos square theta by 2g, which is u2 square cos square theta by 2g. So therefore the ratio of their heights attained, h1 by h2. h1 by h2, that is equal to u1 square by 2g divided by u2 square cos square theta by 2g. So 2g will cancel. So then we will get u1 square by u2 square cos square theta. So this is u1 square by u2 square, and cos square theta, cos theta is u1 by u2. So cos square theta will be u1 by u2 whole square. So this will be u1 square by u2 square into u2 square by u1 square. So that will be equal to 1. So it means the ratio is coming. So the ratio is 1:1. The ratio is 1. So the ratio is told that is equal to 1 by x. 1 by x is 1. So it means x also will be 1. So the value of x is 1. Here it is told if the initial velocity in horizontal direction of a projectile is unit vector I cap, the initial velocity in horizontal direction of a projectile is unit vector I cap, and the equation of the trajectory is y equals to 5x minus 5x square. Then, and the y component or y component vector of the initial velocity is, so g equal to 10 meter per second square. So here you can see that equation of the trajectory is this, and the initial velocity in the x direction is 1 I cap, means simply I cap m- meter per second, means Vx ux, actually initial velocity ux, that is equal to u cos theta, obviously u cos theta, that is equal to 1. Now we know that along x the displacement along the x direction at any time t, that is u cos theta into t, and the and the displacement along y direction at any time t, that is u sin theta into t minus half g t square. So t equals to y equals to u sin theta into x by u cos theta, t equals to x by cos theta, t equals to x by u cos theta, and this is half g x square by u square cos square theta. So therefore the equation of the trajectory is x tan theta minus half g x square by u square cos square theta. So if we compare this equation by this equation, then therefore we will get that y equals to 5x minus 5x square. So therefore y equals to x tan theta minus gx square by 2 u square cos square theta. So therefore tan theta equal to 5, and g, that is 10, g is equal to 10, 10 by 2 u square cos square theta, that is equal to also 5. This is 5, so it means that u square cos square theta, that is equal to 1. The y component we have to find. Y component is u sin theta. Uy, that is u sin theta, which has been asked to find out. So therefore u cos theta, that will be also 1, and tan theta, that is 5. So sin theta by cos theta, that is equal to 5. So therefore u cos theta into tan theta, u cos theta into tan theta, that would be equal to u sin theta. So therefore u sin theta, that will be equal to 1 into 5, that is equal to 5 meter per second. So the y component vector of the initial velocity is 5 j cap. Then here it is told A particle is moving in a straight line such that its velocity is increasing. A particle is moving in a straight line such that its velocity is increasing at 5 meter per second per meter. Okay, means dv by dx. dv by dx is 5 meter per second per meter. It means I can say 5 per second. The acceleration of the particle is at a point where its velocity is 20 meter per second. Therefore, the acceleration, as you know, that is v dv by dx. So we have to find the acceleration when velocity is equal to 20 meter per second. So that will be now the velocity, that the rate of change of velocity with distance along x, that is constant. So v is 20 into 5 meter per second square. So that will be 100 meter per second square. Since v is 20 and dv by dx is 5. So that is 100 meter per second square. And here it is told a car is moving with a speed of 150 kilometer per hour. A car is moving with a speed of 150 kilometer per hour. Car is moving with a velocity 150 kilometer per hour. Uh, and after applying the brake, it will move 27 meter before it stops. So it will come to rest here. At this point, the velocity will be 0 and the displacement will be 27 meter from here as soon as it applies its brakes. If the same car is moving with a speed of 1/3 the reported speed, then it will stop after traveling dash meter distance. So if it is moving with a speed of u by 3, that is 50 kilometer per hour, then after how much distance it will stop, that we have to find. That is x1, suppose. So after how much distance it will stop means v equal to 0, that we have to find out. This x we have to find. So now we can apply v square equals to u square plus 2s. Now here we can assume that when it applies its brakes, its retardation will be constant. A, which is, that is the minus a, which is the retardation, that is constant. Retardation that will be constant. So here we can say that 0 square, that is equal to 150 square. 150 we can convert into meter per second also, that is 150 into 5 by 18, that is 3 6 is 18, 3 5 is 15, 2 2 is 4, no, 2 3 is 6, 225 is 150. So that is 125 by 3 meter per second. And this one will be this divided by 3 again. So 50 into 5 by 18. So that is 2 9 is 18, 225. So this is 125 by 9 meter per second. This will be this will be 125 by 3 whole square minus 2a into the displacement, which is 27. So therefore the retardation, that is equal to 125 by 3 whole square into 1 by 2 into 27. It means the retardation, that is 5 cube, means it is 5 power 6 by 81 into 2. This much meter per second square. Now this x1 we have to find out. Similarly, here we can say v square equal to u by 3 whole square minus 2a into x1. B is 0. So therefore x1 again, that will be equal to u by 3 whole square into 1 by 2a. So which is u by 3, that is 125 by 9, 125 by 9 whole square into 1 by 2a. A is 5 power 6 divided by 81 into 2. These two will cancel out. This much meters. So in meters only we have to find out. So this will be 125 whole square means this is also 5 cube whole square, that is 5 power 6 by 9. This is 3 square whole square, that is 3 power 4 into this is 81 by 5 power 6. So 5 power 6, 5 power 6 will cancel, and 3 power 4 is also 81. This will cancel. So this is 1 meter. So at 1 meter distance it will travel and then it will come to a stop. Then here it is told a car covers AB distance with first 1/3 at velocity v1 meter per second. Means it covers a distance, let's say x, with v1 meter per second, and the second 1/3 distance, that is x, at v2 meter per second, and the last 1/3 distance x at v3 meter per second. And here it is told v3 equal to 3 times v1 and v2 equal to 2 times v1, and v1 equals to 11 meter per second. It means v2 will be 22 meter per second and v3 is 33 meter per second. Then the average velocity of the car is dash meter per second. So therefore the average velocity, as we know, that is equal to the total displacement by total time. Total displacement by total time. So the total displacement, that is 3x, x plus x plus x, 3x meters divided by the total time. Here in the first 1/3, to cover the first 1/3 distance, the time taken, let's say that is t1 will be x by v1. Similarly, the time taken by the second 1/3 distance, that is t2, that will be x by v2 seconds, and t3, that is the time taken to cover the last 1/3 distance, that is x by v3 seconds. So this will be 3x by v1 plus x by v2 plus x by v3 seconds. So that will be equal to, so x I can take common and I can cancel out. This will be 3 by 1 by v1 plus 1 by v2 plus 1 by v3 meter per second. So therefore the average velocity, that will be equal to 3 by 1 by v1, that is 11, plus 1 by v2, that is 22, plus 1 by v3, that is 33. This much meter per second. So that will be equal to 3 by, now if you take the LCM, that will be 33 in, no, that will be 66. 3 into 2, that is 66. Now 11 6 is 66, 22 3 is 66, 33 2 is 66 meter per second. So that will be 3 into 66 by 3 plus 6 plus 5, that is 11. So 11 6 is 66, so 3 6 is 18 meter per second. So 18 meter per second is the average velocity of the car. And here it is told a ball is projected vertically upwards with an initial velocity u equal to 50 meter per second at t equal to 0. At t equal to 2 seconds, another ball is projected vertically upwards with the same velocity. So u equal to 50 meter per second. Another ball b, it is thrown at t equal to 2 seconds. At t equal to dash seconds, second ball will meet the first ball. So first we can find out, so here g equal to 10 meter per second. Now we can find their time of flight. The time of flight of the first ball, that is, let's say t1, that will, let's say t1, that will be equal to 2u by g. So that is 2 into 50 by 10, that is 10 seconds. It means it will reach to the highest point at t equal to 5 seconds. Similarly, the second ball will reach the highest point at t equal to 7 seconds. So here the the concept which we have to apply is the displacement of the first ball in time t at any time t, that will be ut 50 into t minus half g 10 into t square, and the displacement of the second ball at any time t, that will be 50 into t minus 2 minus half g into okay, so S2 will be equal to 50 and into t minus 2, since the second ball starts at t equal to 2 seconds, and this will be half into g into t square, so the time interval will be t minus 2 whole square. Now so at some time, at time t that we have to find, when S1 will be equal to S2, means their displacements will be the same. Therefore S1 that will be equal to S2 at time t. So S1 is 50t minus half into 10 into t square, that will be equal to 50 into t minus 2 minus half g into t minus 2 whole square. So therefore this will be 50t minus 5t square, that will be equal to 50t minus 100 minus 5 into t minus 2 whole square. So this will be 50t, 50t will cancel out, then this will be 100, that will be equal to 5t square minus 5 into t square plus 4 minus 4t. So this will be 100, that will be equal to 5t square minus 5t square plus 20, sorry, minus 20 plus 5 4s are 20t. So t square, 5t square will cancel out, then we will get 20t, that is equal to 120. So therefore t will be equal to 6 seconds. So at t equal to 6 seconds, both their displacements from the ground will be same. So at t equal to 6 seconds, second ball will meet the first ball. Then it is told a fighter jet is flying horizontally at a certain altitude with a speed of 200 meter per second. A fighter jet plane that is flying horizontally at an altitude height of that we have to find out. Okay, height at a certain height it is flying with a speed of u, that is 200 meter per second. When it passes directly overhead an anti-aircraft gun, a bullet is fired from the gun at an angle theta with the horizontal to hit the jet. If the bullet speed is 400 meter per second, the value of theta will be when it passes directly overhead an aircraft gun, a bullet is fired from the gun at an angle of, so here there is an anti-aircraft gun. So a bullet is fired from that gun at an angle of theta with the horizontal to hit the jet. So if the bullet speed, the speed of the bullet, that is u, and speed of the fighter jet, that is suppose v, so u is 400 meter per second, then the value of theta will be, so here let's say it will hit the plane, it will hit the jet plane here. So will hit the jet plane here. So it means at some time t it will hit. So it means that at time t equals to t, the height which is achieved by the projectile, the height which is achieved by the projectile, that should be same as that of the height of the jet plane. So y should be equal to h, and also the x coordinate, that should be equal to vt. So the x coordinate, that will be equal to 400, that is u cos theta. So u cos theta, u cos theta into t, u cos theta into t, that should be equal to v into t. So it means v should be same as u cos theta. It means that 4 v is 200, 200, that should be equal to 400 cos theta. So therefore cos theta, that should be equal to 1 by 2. So theta should be equal to 60 degree. So if it is projected at an angle of 60 degree, then only it can hit the jet plane. And y, which is equal to uy into t, that is u sine theta into t minus half gt square, that should be also equal to h. So from here we can find out what should be the height. So here the value of theta should be 60 degree. Then here it is told a ball of mass 0.5 kg is dropped from the height of 10 meters. From a height of 10 meters, the ball of mass 0.5 kg has been dropped. So it is dropped, it means its initial velocity will be 0. So the height at which the magnitude of velocity becomes equal to the magnitude of acceleration due to gravities. So the height, let's say that is x from the ground. So we have to find the value of x at which the velocity, that is equal to g. So v, so as you know, v square equals to u square plus 2as. So here the, let's say we can take the vertically downwards as the positive direction. Then it means acceleration will be equal to plus g. G is equal to 10. And so the displacement, that will be equal to this h minus x, that is equal to 10 minus x. So therefore v square, v is equal to g, so g square equal to 0 square plus 2 g into s, s is 10 minus x. Therefore 10 square, that is equal to 20 into 10 minus x. So therefore 100 by 20, that is equal to 10 minus x. So 25 is 100, so it means x will be equal to 10 minus 5, that is equal to 5 meters. So at height of 5 meters, the magnitude of velocity will be same as the acceleration due to gravity. Then it is told here that a body is projected from the ground A body is projected from the ground at an angle of 45 degree with the horizontal. Here theta is 45 degree. Its initial velocity, okay, okay. Initial velocity is not told. So let's say its initial velocity is u. Its velocity after 2 seconds is 20 meter per second. So at t equals to 2 seconds, its velocity is 20 meter per second. Then the maximum height that is reached, h max, reached by the body during its motion is dash meters, and g is 10 meter per second square. The body is projected from the ground at an angle of 45 degree with the horizontal. Okay. So as you know, the maximum height reached, that is equal to u square sine square theta by 2g. So here theta is 45 degrees, so it will be u square by 4g. Then sine 45 degree, that is equal to 1 by root 2. So sine square 45 will be 1 by 2. So u square by 4g. Now v, that is given as vx square plus vy square. Now vy, that is equal to uy, that is u sine theta minus gt, and vx, that is equal to u cos theta. So that is u by root 2 here, and this is equal to u by root 2 minus gt. Since y cos theta cos 45 and sine 45 is same, that is equal to 1 by root 2. Now v, that is equal to v square vx square plus vy square, that is equal to 20 velocity at 22 second. Okay. So now therefore velocity, that will be equal to u by root 2 whole square plus u by root 2 minus gt whole square. Now that is equal to 20 at t equal to 2 second. So therefore we can find the initial velocity here. So this will be u square by 2 plus u square by 2 plus this is g is t is 2. So plus 2g whole square minus 2ab. So 2 into u by root 2 into 2g. So that is equal to 400, which is 20 square. So this will be equal to u square plus 20 square minus 2 root 2 into 10 u, that is equal to g is 10, that is equal to 400. So 400 and 400 will get cancelled. So u square minus 20 root 2 u, that is equal to 0. So therefore u into u minus 20 root 2, that is equal to 0. So therefore u cannot be 0, so u should be equal to 20 root 2 meter per second. Now therefore the maximum height reached, that is equal to u square by 4g. Square by 4g. So u square is 20 root 2 into 20 root 2 divided by 4 into 10. G is 10. So 10, 4, 5 is 20. So 5 2 is 10, 10 into 2. So that is equal to 20 meters. So the maximum height reached by the body will be 20 meter. Here it is told from the top of a tower, a ball is thrown vertically upwards. Here a ball is thrown vertically upwards, which reaches the ground in 6 seconds. So the time of flight is 6 seconds. The ball thrown a second ball thrown vertically downward from the same position with the same speed reaches the ground in 1.5 seconds. So if here the initial velocity is u, here the initial velocity is u, which is downwards, then here the time of flight for the second case, that is 1.5 seconds, and time of flight for first case is 6 seconds. A third ball is released from rest from the same location, will reach the ground in how many seconds? So if u is 0, then what will be the time of flight? That is t3. That is how much? So here, let's say the height of the tower is h. And here we can say s equal to ut plus half at square. Now, if we consider the vertically downwards as the positive direction of y-axis, then in the first case, in the case 1, the initial velocity is minus u, since it is vertically upwards. So since we take vertically downwards as, if we take vertically downwards as positive, then vertically upwards will be negative. So in the first case, the displacement is h, which is equal to minus u into the time is 6, and then plus half g into t square, which is 6 square. And case 2 is h, that is equal to the initial velocity is downwards here, so it will be u into 1.5 plus half g into 1.5 square. And case 3 is height, the displacement is h, and initial velocity is 0, and time we have to find, which is t3 plus half g into t3 square. So t3 we have to find out. Now here, if we take the first case and the second case, then we can say that 6 minus 6u plus 18, 2 18s are 36, plus 18g, that is equal to 1.5u plus, this is 1.5 square by 2 into g. So therefore we can say that 7.5u, that is equal to 18g minus 1.5 whole square by 2 into g. Therefore u will be equal to 18 to the 36g minus 1.5 square g by 2 into 7.5. So therefore u will be equal to 36 minus 2.25 by 2014 15 into g, which is equal to, this will be 34, so this is 33.75 by 15 into g, and this will be 15 to the 30 into the 30 30, this is a 45, again 15 to the 30, 15 5 is a 75. So this is 2.25 g, u equals to 2.25 g. Therefore the h will be equal to minus 6u plus 18g. So this will be equal to minus 6 into 2.25 g plus 18g. So this will be 18g minus 6 5 is a 30, 6 is a 12, 6 is a 30, 6 2 is a 12, 15, 6 is a 12, 13, 13.5 g. So 18 minus 13.5, that is equal to 4.5 G. So H equal to 4.5 G. So therefore, the in the third case, the time that it will take to reach the ground, so that is equal to H, that is equal to half, H equal to half G into T3 square. So therefore, this will be 4.5 G, that is equal to half G into T3 square. So G and G will cancel. So T3 will be T3 square, that is equal to 4.5 into 2, that is equal to 9. So therefore, T3 will be equal to 3. So in 3 seconds, it will reach the ground. In 3 seconds. So it will reach the ground in, the third ball will reach the ground in 3 seconds. Then here it is told the ranges and heights of two projectiles projected with the same initial velocity at angles 42° and 48° with the horizontal are R1, R2 and H1, H2 respectively. Choose the correct option. Now we see that 42 plus 48, that is equal to 90°. So it means their ranges will be the same. Since why? If the angles of projection, if theta 2 that is equal to 90° minus theta 1, then if theta 1 and theta 2 are the angles of projections, then the ranges will be same. R1 will be equal to R2. So here also the same thing will happen. So R1 will be equal to R2, and H1 will be equal to u square sine square theta 42° by 2g, u square sine square theta by 2g, and H2 will be equal to u square sine square 48° divided by 2g. So therefore sine square 48°, we can say that is equal to cos square 90° minus 48°, that is equal to 42°. So it is same as cos square 42°. So now when you know that when theta is from 0 to 45, from 0° to 45°, then uh, sine function sine theta will be less than cos theta. Suppose, for example, cos 30 is root 3 by 2 and sine 30 is 1 by 2. So cos 30 is more than sine 30. So sine theta is less than cos theta. So it means that sine 42, so it means I can also say sine square theta will be less than cos square theta for all angles of theta from 0° to 45°. So therefore I can say that sine square 42°, that is obviously less than cos square 42°. Therefore, so I can say that this sine square 40°, we can say this is cos square 42° by 2g, u square cos square 42° by 2g. So therefore now u square sine square 42° divided by 2g, that will be obviously less than u square cos square 42° divided by 2g. So it means obviously h1 will be less than h2. H1 will be less than H2. So it means that R1 equal to R2 and H1 is less than R1 is less than R2 and H1 is less than H2. H1 is less than H2. So option B is the correct answer. Then here it is told a helicopter is flying horizontally with a speed. Helicopter is flying horizontally with a speed V at an altitude H, has to drop a food packet for a man on the ground. What is the distance of the helicopter from the man when the food packet is dropped? What is the distance of the helicopter from a man? So it should throw a food packet from the helicopter. So it will fall in a parabolic path. Food packet is thrown by the helicopter to reach the man who is on the ground, So now so here it is asked what should be the distance of the helicopter from the man, means this length d we have to find out. So now here the range we have to find, range is x and the vertical height is h. So d will be obviously root over x square plus d square plus h square. So okay, now the horizontal range, that will be equal to v into the time of flight, so the time of flight will be obviously equal to root over 2h by g. Since why, I will tell that h will be equal to half gt square. So t will be equal to, where t is the time of flight. So therefore x will be equal to v into root over 2h by g. So therefore d, that will be equal to 2h v square by g plus h square. 2v square h by g plus h square. So it is option C is the correct answer. Then here it is told water drops are falling from a nozzle of a shower onto the floor from a height of 9.8 meters. The drops fall at regular intervals of time. When the first drop strikes the floor, at that instant, the third drop begins to fall. Locate the position of the second drop from the floor when the first drop strikes the floor. Locate the position of the second drop when the first drop strikes the floor. The drops fall at regular intervals of time. So the first drop will reach the floor in a time. The time interval it will take, that is h equal to half gt square. G is 9.8. So 9.8 equals to half into 9.8 into t square. So 9.8 will cancel. So t square, that is equal to 2. So t will be equal to root 2. Okay. Okay. So the time that the first ball will take to reach the ground, that is root 2 seconds. So therefore, at t equal to root 2 seconds, the third ball uh, will start to fall. And at t equal to root 2 seconds, the first ball will reach the ground. And the second ball will be somewhere here. Let's say this height from the ground, that is x. Locate the position of the second drop from the floor when the first drop strikes the floor. So this x has been asked. So this distance is h minus x, which we have to find out, which we can find out. Okay. So it means that if the uh, so the drops fall at regular intervals of time. So it means if the time interval, if that regular time interval is, let's say, delta t, then it means that 2 delta t, since why uh, the the second drop will start to fall off at, so the first ball will start at t equal to 0 and the second ball will start at t equal to delta t. and the third ball will start at t equal to 2 delta t. So it means that 2 delta t will be equal to root 2 seconds. So it means delta t will be equal to 1 by root 2 seconds. So the time interval, the regular time interval after which each drop will fall, that is 1 by root 2 seconds. So it means that the the time interval for which the second ball has fallen, that will be t1, that is root 2 minus delta t. So for this time interval it has fallen, which is root 2 minus 1 by root 2 seconds. So for this time, how much is the displacement of the second drop? That is h minus x. So therefore I can say that for the second drop, it has fallen for time interval t1, that is root 2 minus 1 by root 2 seconds, and it covers uh, and it has a displacement. It has a displacement of um, it has a displacement of, that is how much? That is h minus x m- m- meters. H minus x meters. So therefore I can tell h minus x, that is s equal to ut. U is 0, so it will be half g into t square. So t is root 2 minus 1 by root 2 whole square. So from here we can find out x. And g, okay, so g is 9.8. So therefore we can tell h, that is 9.8 minus x, that is equal to half into 9.8 into, this is 2 plus 1 by 2 minus 2ab, a square plus b square minus 2ab minus 2. So this will be half. It means 9.8 minus x, that is equal to 9.8 divided by 4. So it means x will be equal to 9.8 minus 9.8 by 4, which is equal to 9.8 into 1 minus 1 by 4, that is 3 by 4. So this will be 4 to the 8, 4 4 the 16, 4 to the 8, 4 4 the 16, 4 5 the 20. So it is 3 into 2.45. So that is 3 5 the 15, 3 4 the 12, 13, 3 to the 6, 7, 7.35 meters from the ground. So the position of the second drop from the floor when the first drop strikes the ground will be 7.35 meters. So option D is the correct answer.